OK, so let's go over this problem. So I have g plus 3h equals 8, and 1/3 g plus h equals 9. Now remember, whenever we're doing substitution, we always want to look for the variable that is the easiest to solve for, right? And the easiest variable to solve for is one that's going to have a coefficient of 1. So we look up here, and we notice that both of my variable, I have two variables that have a coefficient of 1, right? I have this g has 1, and this h has 1. So I could actually solve for both of them, correct? Right. Now, I see a fraction here, and I automatically know, you know what, I'm going to have issues with fractions. So I want to see, is there a way to get rid of fractions? And let's take a look at a little bit of an experiment here. Let's say I had 3x plus 4 equals 16. Yeah, let's do that. OK, everybody know what the answer is on this? I don't. Let's do it this way, though. OK, everybody know what the answer is? Yeah. What's the answer? 3. X equals 3, right? What about if I multiplied everything? Let's say I do multiply everything by 1/2. Right? Then I get 2x plus 2 equals 8. Right? What's my answer? 3. So it's the exact same, right? So do you guys notice, as long as if I multiply my whole equation by a number, it doesn't matter what that number is my equation still the same? Yeah. Yes. So how do I get rid of a fraction, first of all, right? Multiply by the reciprocal, which would be 3 over 1, right? So is it OK then if I multiply 3 times everything? Am I still going to have the same answer? Is my equation still the same? Yes. So what I'm going to do is show you how to multiply that. So when I multiply everything by 3, I get g plus 3h equals 8. And then this just gives me g plus 3h equals 9. Now, before even doing substitution, I'll go through the substitution process with this, but I want to take you guys a look at this. You can, yes? Wait, where do you multiply 9 by 3? Yes, you do. Good. You got to make sure you multiply everything by 3, right? Now, when you guys are looking at this, one thing I want you guys to remember, when you have equations, before I even do substitution, right? Because, yeah, you guys can do the substitution method from here if you guys want to. But I want to kind of show you a little shortcut if you need it. This is standard form, right? Does anybody remember what the slope is in standard form? Anybody remember what the slope is? No? Anybody? You guys all forgot? Your slope is opposite of A over B. Do these have the same slope? They do then, right? So what type of lines are going to have the same slope? Remember we looked at graphing? Parallel lines have the same slope. And what about if they're the same line? Would they have the same slope as well? Yes. So therefore, I'm either going to have the same line or I'm going to have parallel lines. Now, are their y-intercepts the same? Are these exactly the same equations? No. So they're exactly the same line? No. So therefore, these are what we call parallel lines. And if you guys remember parallel lines, do they have a solution? No. They don't have a solution, right? They don't intersect. So therefore, I don't actually even have to do substitution on this. And I understand that these are already parallel lines. However, to practice substitution, right, you got to solve for your variable. So let's just do one of those. Let's solve for a variable. I don't know. Let's solve for this. Let's solve for this one since it's right here. Yeah. So let's solve for this one. Minus 3h on both sides. So I get g equals negative 3h plus 27, right? Plug that into the top equation. Remember, since g equals this, I can substitute that value. And the reason why we do that is because now I only have one variable. And what you guys notice is my h's add to 0, and I'm left with 27 equals 8. And is that true or false? False. Therefore, that's the other way that we show that we have parallel lines. OK? Because there's no solution. So they have parallel lines. Make sense? OK, there you go.